3 missing orthographic view example problems, specifically all missing front view problems. We'll step up in difficulty from easy to medium to hard, and this last one has some parts that are really tricky on it. But all 3 drawings are going to use the same fundamental techniques. That is, we're going to use the right side and top view, line up features on those 2 views via the mitre line, figure out which part of the right view corresponds over to part of the top view, and once we figure out which parts match up, we match them down to the front view and then draw the front view drawing. Problem number 1 looks like it has entirely horizontal and vertical faces. There's no diagonal lines drawn anywhere. So I'm going to make an assumption that all the faces are horizontal and vertical, and I'm going to start off by marking each visible face. So there's 1, 2, 3 on the top view, 4, 5, 6 on the right side view. In orthographic projection, like a vertical or horizontal flat face on one view will appear as an edge or just a line on the other 2 views. So for each of these 6 visible faces, if we can find the one line that corresponds to it on the other view, we'll be able to line up the face with that line to draw ourselves a single line on our front view. So these 6 blue rectangles will let us draw 6 straight lines on our front view. And that's going to give us most of the shape. And then to finish the drawing, we'll use those lines and sort of make some guesses as to where the rest of the lines go and kind of double check. So face 1 on the top view, if I trace this across and down from the mitre line, shows that it's basically that short left section on near face 6. And when drawing the line on the front view, I can go straight down from face 1, right? The front view and top view are aligned horizontally, so things line up straight vertically. The front view and right side view, features on them line up horizontally. That is, height on one is the same as height on the other. So when I go down from face 1 and over from face 6, that gives me this horizontal line that corresponds to sort of the edge, the front corner of face 1. And I can do the same thing then for face 6 from the right side view. Again, trace it up. It corresponds to this vertical yellow line on the top view. So when I trace that vertical line down and then face 6 over, this gives me a little vertical line on the front view that's the same height as face 6, but has the same horizontal alignment as that vertical line that's on the top view. Now I'm making a bit of a guess here. So between faces 2 and 3, there's a thick visible line, which means that faces 2 and 3 are at different heights. So I'm making a guess that height 2 is taller and height 3 is lower. And on my right side view, that's going to mean that if 3 is lower, it's going to correspond then sort of to face 5. And then face 4, which is a little bit higher, is going to sort of correspond to face 2. And the reason that I think that 3 is going to be lower is because on the right side view, between faces 4 and 5 is a visible line. If the line between faces 4 and 5 were hidden, then that would mean that there is a big flat face on the right side, and that would mean that side 3 is taller, was the full height. But since that's visible on the right side view between 4 and 5, that means that face 5 is really short, and that probably corresponds then to face 3. So when I look at face 5 on the right side view, that looks like it should correspond then to the very first visible face all the way on the right side next to 3. So that's why I'm putting this 2 square height line that's the same height as 5, but is located at the right side of face 3, because that's going to be the shortest part. So at then face 4 on the right side view is going to correspond to the left side of 3, or the area between 2 and 3 on the top view. And so when I draw my line on the front view, it's going to be horizontally aligned with face 4 on the right side, because the front and right are horizontally aligned, and it's going to be vertically aligned with between faces 2 and 3 on the top view. So face 3 on the top view, again, I'm already kind of assuming that that's the the edge between faces 4 and 5 over on the right. So line these up and I now have sort of a staircase shape and my front view is starting to take form a little bit. And last one is going to be face 2 on the top view, which again, if this is all the way at the top, it's going to be all the way at the top. And so on my front view, I'm going to draw it all the way on the top. So now I've got 6 lines drawn on the front view corresponding to the 6 faces on the other 2. To finish the drawing, I need to try and guess a little bit what are the actual faces here on the front view and try to match those up with edges on the other 2. And if I look at the bottom, it looks like this bottom front, these 2 lines here are probably a full rectangle. You should probably be able to see the bottom of the object. And so I can see that these are going to correspond to the bottom of 1 on the top and the left of 6 on the right. And I'm just going to go ahead and draw in this rectangle. That seems like that's probably gonna finish the shape. The next one's a little bit tougher, where I'm just going to assume that this whole zigzag is one big shape also. I really want to finish the bottom line all the way across, and I want to finish the vertical line all the way on the left-hand side. And it seems like that should work because on the top view, there's a horizontal line all the way across. On the right side view, there's a vertical line going the full height. And so that's going to let me finish and darken in these shapes. But now what about the hidden lines, right? We did all the vertical lines first. We completely ignored the hidden lines, but now we look at hidden lines. Normally, when you see a pair of hidden lines, you should be thinking circular hole. That is usually what they represent. However, there's a giveaway in this case to show why that's not true, and that is that we are missing a center line. If this were a round hole, there would be a center line visible on the top view. Now, very tricky, there would not be a center line on the right side view because visible lines have priority over hidden or center lines. So there actually would not be a center line drawn on the right side view because the visible line would be blocking it. But since there's no center line on the top view, that means that this is not a circular hole, which means it's probably a rectangular hole. So we'll just go ahead and draw this in then as a square hole right through the middle of the shape. And that's it. Problem 1 done. Probably pretty tough your first time through, but this will get a little bit easier the more you practice. Now, before moving on to the next problem, I want to say that this solution is not unique. There's actually another possible correct answer. Over here on the stair-step portion, this could actually be a diagonal line across instead of a vertical and a horizontal. Because a diagonal line on one view, or an angled face, a diagonal line on one view is going to look like a surface on the other 2. And that's because when you have a diagonal line, when you look from the top down, you see the face. And when you look from the right, you also see the face. So this staircase, like where we have a horizontal surface visible from the top and a vertical surface visible from the right, could also be a single diagonal surface that's visible from both. So we don't have enough information to actually decide which of these is correct, the diagonal or the staircase. So I'm going to stick with the staircase design, but if you wanted to draw that as a diagonal line, that is also technically correct, and there's no way to figure out which one is more correct. Your TA Serenity's second favorite treat is when you hit the thumbs up button. So if you're learning something today, her first favorite treat is definitely the churros. She loves those like crazy. But if you think you're learning something, go ahead and hit the thumbs up button to let your TA Serenity know she's doing a good job. And we'll go ahead and move on to drawing number 2. Gonna start off the same way by dividing my top view and right side view into all of the visible faces, because again, a visible face on one view is going to be an edge or a line on the other 2 views. So I've got 4 visible faces on top and 2 visible faces on the right. Now I'm making a first sketch here as to what I think the final shape might end up looking like. It's probably going to be wrong, but it gives me sort of a starting point just as I start making the front view to make sure I don't go wildly off track. And basically I'm just trying to draw something that has 4 different heights. That's what I can tell from the top view, that there's Since it's divided up into 4 rectangles, each of those 4 rectangles is probably at a different height from each other, including those 2 and 3 need to also be at different heights. So again, the final drawing is probably not going to look like this, but it sometimes helps me visualize what I'm drawing if I start off with something, even if it's wrong, and I'll try to fix it later. And of course, I discovered right off the bat that it's definitely wrong, because when I look at the right side view, that big face, face 6, that connects the bottom up to the top, means that when viewed from the right side, that height 4 has to be all the way at the top, because again, there's a flat face visible on the right that goes the full height. If 4 were shorter, there would be more visible lines throughout the drawing. So this lets me draw a line that is corresponding to the top of the right side face that corresponds with the width of height 4 on the top. I know 4 has to be at the full height. Now on the right-hand side, face 5 is also visible. And so this means that it needs to be kind of in front. It needs to be like the first face that is recognized. And so face 3 is again that lower half of the top view, which corresponds to the left half of the right side view. This lets me draw a horizontal line on front that is the width of 3, but is at the same height as the lower part of 5. So this is the line that corresponded to face 3. For face 2, it can't be at the top height, because if it were all the way at the top, there would not be a visible line between 2 and 4. So face 2 has to be lower than 4, which means that it could be either of the 2 visible lines on the right-hand view. It can't be the center line, because if there were actually a hidden line there, the hidden line would have priority over the center line, and the center line wouldn't be drawn. So I'm going to make a guess and assume that face 2 is at the top hidden line, but we'll kind of need to check that later on. It could maybe be at the lower hidden line. Now, interesting for face 1 is, I said at the beginning that all 4 of the top views would be at different heights, but actually 1 and 4 can be at the same height. Of those 3 surfaces, they only have to be different heights than the ones they are touching. So surface 2 needs to be at a different height than 1, 3, and 4 because it's touching all of those and there's a visible line separating it. But 1 and 4 are not actually touching, and since 1 is the full height of the top view, which means it's the full width of the right side view, there are no visible or hidden lines that go the full width of the right side view, except for the very top. So this means that height 1, face 1, needs to actually be all the way at the top. You can't tell, looking at the right side view, whether face 5 is like we're looking at the bottom of a hole or we're looking at the top of a protrusion. Like, is 5 sort of sticking out or is it sunken in? It makes most sense to me that 5 is going to be sunken in to the surface. So I am going to assume that this visible face 5 actually corresponds with this check mark between faces 1 and 3 on the top view, and not between faces 3 and 4 on the top view as if it were in the front. Because it seems like face 3 is going to be that flat face, which I think on this drawing is going to end up being kind of open and not enclosed. So that's why I'm going to draw this face 5 on the back side, on the left side of front. But we might want to come back and check that later on just to be sure. And lastly, if I look at the big surface for 6, this should correspond to the big vertical line on the right side of top view. So this should give me a big vertical line on the right side of front view also. So I've now drawn 6 lines on my front view corresponding to the 6 visible faces on right and top. And now the goal is to look at my front view and try to fill in the gaps, fill in the missing pieces where a face on the front view is going to explain individual lines on the other 2 views. So the first question mark is this horizontal line on the top view. I can view that, instead of viewing that as just a separate line, a separate feature, what if I viewed that whole section on the top view as one big flat rectangle? What that would mean is that on the front view, this flat face isn't only length 3, it's actually length 6. So it's like a whole lower shelf all the way across. And that would mean that I've basically got a big, low, flat surface across most of the shape. And that would explain what that horizontal line is on the top view. Now, I'm next just gonna go ahead and assume that viewing from the front, this is a whole huge blocky shape. So I'm gonna go ahead and just draw the left-hand vertical surface and the big flat surface along the bottom. And I'm also gonna go ahead and make a little connection here. You're definitely gonna be able to see something there. So just sort of filling in some of the gaps. And the big question then kind of is what's going on here in the middle and what's going on with those diagonal lines. So now looking at this highlighted horizontal line on the right side view, that's something that as of yet has no corresponding lines on the front view. And since it's a visible line on the right, that means it originates on the far right side of the front view, right? If it's visible on the right, it's on the right side of front. And that from the top view, we can see that things that are on the right-hand side go that, 3 squares in. So I'm going to draw myself a horizontal line 3 squares in from the right that's going to correspond to this, again, yellow line here on the right side view. And then to just sort of finish up this shape, I'll draw myself a vertical line that sort of connects from all the way to the top, all the way down to not just this section, but a little bit further below, down to where I have my middle height drawn. And the drawing is now starting to come together a little bit, but there's still some pieces that are not explained. There's still hidden lines on the top view and still some hidden lines on the right side view that don't have corresponding features on the front yet, so we gotta look at those. Well, since they have center lines, center line means round hole. And so we can just line up from the top view and from the right side view, just line those up, draw ourselves a hole, give us some center lines, and boom, done. So let me try drawing another quick isometric sketch here, way better than my old one from before, which was totally wrong, to try to explain and see if this shape actually makes sense, see if I'm still missing anything. So I draw a total height on the left and on the right, and I've got a big flat shelf in the middle, and the right-hand part sort of protrudes like an overhang, and then there's a part in the middle that's sunken down, and I draw the hole. And the main question is these purple circles. Is this part correct? This is definitely the hardest part to be sure of. There's a little bit of ambiguity, like on the right side view, where I wasn't sure whether this horizontal shelf should be at the top of the hole or the bottom of the hole. And in fact, there's actually no way for me to tell. So it is possible that this middle shelf section should actually be aligned height-wise with the bottom of the hole. In fact, it's completely ambiguous. There's no way to tell from only these two views what height it should be at. So I'm gonna go ahead and stick with this one. But if you had drawn that middle shelf at the bottom of the hole, that would also be correct. There's no way to tell the difference. Well, if you didn't think TA Serenity was helping out before, maybe you'll give a thumbs up to your TA Indiana. I'm giving him his Churu treat. He loves thumbs up also though, so if you want to hit the thumbs up, that would be hugely appreciated. He loves those. Fair warning, this one is a huge step up in difficulty dealing with that round section in the middle. This is probably the most complicated drawing I might give to a first-year engineering student in a basic engineering drawing class. Again, I think this is about as hard as it's gonna get, I think. But I'm still starting off the same. I'm drawing my mitre line and I'm drawing 3 visible faces on the right side view. And I kind of want to see what those correspond to on the top view, just to help get me started. From a completely blank page, just start giving yourself a couple of individual lines. Don't worry about drawing entire faces on the front view. Draw the easiest lines that you can first, and then we'll worry about connecting them and making faces later at the end. The hard part about this shape, as you can see from the right side view, there's a diagonal line, and the diagonal line is cut through the cylinder. And that's gonna be super hard to draw, but in the middle of face 2 on the right side, we have these 2 little hidden lines which indicates a hole, and those holes are on the left and right sides of the top view, which shows to me that the big sections on either side are gonna be elevation-wise, the same place as surface 2, so not all the way at the bottom, kind of in the middle. And then for face 3, that's drawn all the way at the bottom, we see that the hidden lines through face 3 are all the way on the outside. They're the same hidden lines that go through the entire height. So face 3 actually corresponds to that cylinder that's in the middle. So basically the cylinder goes from top all the way to bottom, and then there's two pieces that kind of jut out to the sides, not all the way at the bottom, like kind of towards the bottom at the same elevation of surface 2. So that gives us general structure. We're gonna have a cylinder in the middle, these two flat wings sticking out to the sides, and those wings are gonna be below the middle, but not all the way at the bottom. So let's go ahead and draw those wings first. I'm lining up the horizontal level from the right side view, face 2. And then from the top view, I can put these arrows pointing down, right? The point all the way on the edge is gonna come straight down. And then there is actually a corner here. If these round surfaces on the side were actually tangent, right? If they were actually a smooth curve, then you would not see a visible edge on the front view. But you can tell based on this radius that the height is way taller than the width. So we're not seeing a full 180 degrees of a circle. So since this is less than 180 degrees of circle, there will actually be a corner here, which means you will actually see vertical lines there on the front view. And now how far in do those wings go towards the center? They don't go only to the edge of the cylinder. They go all the way to where the cylinder meets the front, basically where the cylinder gets cut. At that corner where the cylinder gets cut, that's where we'll see the vertical lines here. And actually, after drawing those, that might not be correct. I actually think these two vertical lines in the middle might not need to be there. I think it actually should only be two horizontal lines just ending with just sort of a gap in between. The line just sort of stops because the vertical part of the cylinder should be flat connected into it. There shouldn't actually be an edge there because there's not actually a corner there. Okay, so one mistake, but let's keep going. A cylinder looks like a circle from one perspective, but when you rotate it, it just looks like a rectangle from the other perspective. So this cylinder is a circle from the top, but viewed from the front, it's just gonna look like a rectangle. So on my front view, I'm just gonna draw the full width of the cylinder, both at the bottom of the part, and then also here at the middle of the part. Again, the cylinder is just gonna look like a rectangle from the front view. And then also even from the top of the cylinder still has a flat that goes all the way across. And that's gonna leave me trying to figure out what is this actually gonna look like in the middle, right? Where we have this diagonal line. So I'm circling here in red a really key point. This point on the right side view where the hidden line meets the diagonal line. And then and we can see by tracing up across the mitre line that sort of corresponds to the bottom of the hole, the circular hole on the top view. And if I sort of trace down from the top and over from the front, that gives me where that bottom front quadrant of the hole is going to be located. And I can do the same thing for the left and right quadrants of that hole. They are going to be lined up now with the top of the front view, and then the left and right quadrants. And this lets me draw basically this arc that is the hole, even though it's at an angle, by just lining up these three quadrants. And I'm going to be able to do kind of the same thing for the outer circle, right? The outer surface of the cylinder, right? On the right side view, it's this front lower corner of the diagonal line. And on the top view, that's going to correspond to these two corners where again, like the sliced cylinder touches the front. So I can trace those parts down, right? And so my arcs don't come all the way to a point. They only come in there, and they're just gonna be connected by a flat surface then, where it actually meets the front view. And a little sketch over here to the side kind of shows, so what happens if I take a full cylinder and like slice off part of the front? Well, you can see like a rectangle where it's sliced, but then you also see like the rectangles on either side as well. So that's how I am finishing my shape, is I'm giving myself this little rectangle in the middle. That's the sliced off part that corresponds to like the flat front section. But I'm also giving myself the full rectangle all the way along the outside, because you would still be able to see even beyond the front surface. You'd be able to see the full width of it that goes the full height. And again, these two little short lines where the wings match the front flat face, those two little sections should not actually be there. Those two little lines should be removed. Yeah, that was just kind of a mistake on my part, but that should be a single continuous flat sort of cross shape across the front. So I'll add vertical hidden and center lines for the two holes on the side, vertical center line for the hole right through the middle, and now I'll kind of erase some construction lines, and it seems like, all right, I think maybe that's actually it. And for me, based on this cylinder sliced off through the front and sliced diagonally, and those two slices kind of matched together, visually, spatially, this is probably about as hard as it's going to get, this sort of missing view type problem. Maybe later in the class, once you get a lot more practice, you might do harder things, but early on in the semester, this is super tough. So if you made it through, if you kind of were able to follow along, if you understand this a little bit, you're really doing pretty good. That's something to really be proud of. But if watching this, you look at it and you're still a bit overwhelmed, like there's no way I could do this on my own yet, then go ahead and jump into this next video, which is more practice problems for missing orthographic views.